Hello, it's David. Today I'm talking keyboards, specifically this Atari ST keyboard. Now this is one of two keyboards that I have. One's in my Falcon and that's genuine original, and this is from my STE. But I have three machines. I've got my STFM motherboard as well, and I don't really want to go and buy a new keyboard just for the STFM motherboard. I might as well just buy the whole STFM. The idea was that would just be a parts project, and I'd add things to it. But switching between my STE keyboard here and my STFM when I need to debug that is proving a nuisance. And this one is slightly damaged anyway. The mouse and the joystick are on the bottom of the STE keyboards, and the joystick port is stuck constantly right. I need to take this whole thing apart and refurbish it, and I'd like to have a keyboard in the meantime. So what I was thinking about is, as I do so often on this channel, what can we do with modern technology to replace the keyboard on my STFM? So the way the ST keyboards work is that there's a chip on the back here that's colloquially known as the Intelligent Keyboard Controller, IKBD. And this is an Hitachi HD 6301 chip. This scans the keyboard membrane. It also handles, like I said, the mouse and the joystick ports, and it communicates with the ST itself over a serial line. Now this is an 8-pin connector that goes into the motherboard. This carries, one of the pins is not used, this carries obviously 5 volts ground, the serial transmit and receive, and it's also got an LED light there for the hard disk and the floppy disk, and a reset line. But really all you need there is the transmit and receive ground and power. So perhaps we could get a modern piece of technology to emulate that serial protocol and allow us to use a modern USB keyboard on the ST. Now in the past I've built a project, or I've built a variation of a project that does this for the mouse itself. So this is the Smalliermouse, which is a variant of Simon Inn's Smalliermouse 2 project, which is specifically designed for the ST. This is a small little form factor that's designed to fit in here under the keyboard in the ST and Falcon's keyboard mouse port well, and allow you to plug in a USB keyboard, and that emulates the quadrature USB mouse, and lets you emulate the quadrature mouse using modern technology, and that uses an Atmel AT. So that's an AT90 USB 1287 chip, which provides USB hosting. So perhaps I was thinking I could extend this chip to support IKBD and do the mouse and the keyboard combined. But I thought perhaps somebody has already done this. So I went searching around on the web, and I didn't find anything using the AT90 USB 1287 there. But I did find the old Eiffel project. Now Eiffel's been around a long time, and it's great. It does everything I want. It emulates the IKBD. It allows me to plug a relatively modern keyboard and mouse in, and it emulates the joystick ports, which obviously you'd lose if you don't have the keyboard. But unfortunately that's only for the PS2 protocol, which is a lot more similar to the old mouse protocols than the modern USB standard. Then I came across this project by FieldOfCows. Now I'm sorry, I can't find the guy's real name to credit him, but this actually does exactly what we want. This uses a Raspberry Pi Pico, which has a great advantage at the moment in that you can actually buy it. So it takes a Pico, does some level shifting, it's got an OLED status screen, it's got some configuration buttons, it can take the two joystick a double joystick input, the normal DE9 sockets, but also it allows a single USB hub to be connected so you can connect a mouse and keyboard, a modern mouse and keyboard, or even support modern game controllers. Now this is intended to plug in to a Mega ST, which has an external keyboard in the first place, and so it's designed that there would be an RJ12 jack going on the front. But the difference between the Mega ST's RJ12 jack and the ST keyboard is only, I believe, the reset line, possibly the LED. I think the LED is in present, so it's only the reset line. The only ones, as I said, really matter are the four, the power, the ground, and the transmit and receive lines. So that should be entirely possible to adapt to our conventional STFM, STE, even the Falcon models. So I'm going to get ordering those components, and I think we'll have a go at building that up. So I've just got my level shifter module and my OLED display here through the post. The Pico's been flashed, but I have no way of checking yet to see if it's working. So before I solder it all up, what I thought I would do is to get the breadboard out here and attach our OLED display to it, and let's just see if we can wire it up and see that we've got some signs of life before we commit to soldering it. So I'm just going to bring in 5 volts from a mobile phone charger over here. I'll plug that in. Look at that! There we go. We've got a menu. USB keyboard, USB mouse, joystick, and Joy 0 enabled. Mouse speed setting there. Brilliant. I mean, the configuration obviously requires buttons, which I haven't wired up, so no surprise there. And it's come up with USB keyboard 0. So perhaps if we were to apply 5 volts externally and plug in a keyboard, we could get some feedback on that. So I now plan to breadboard this up a little bit, and we'll get it tested with the ST. But what I'm going to do is only solder the pins that I need to at the moment, because if I convert this into a motherboard of its own later on, it'll make it easier to desolder the Nano instead of having it plug in. It's got castellated edges, you see, all the way around the sides. You can see that they're plated all the way through, and that actually allows you to solder the whole unit easily onto a board. So I might keep my options open to do that by putting in the pin headers, but only soldering the pins that I need. So looking at the manual here, I think for the bare minimum we're going to need, obviously there's ground and power. There's the transmit and receive lines that are going to go through the buffer. There are the SDA and SCL lines that are going to come to here. There's the 3 volts line that's going to go to there. And potentially the buttons, the configuration buttons. I might solder those in as well so that I can, on the breadboard, install some buttons and control it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I only need to do 10 pins in total on that. And this tiny little level shifting module that I got off eBay. To be honest, if I were to do this in a proper circuit board, I think I would install proper level shifting buffers. But this tiny little board here, so this type board I'll probably just solder up all the way. Okay, so there we go. That, I believe, is it all breadboarded up. So the fly wires, the fly pump wires here will go to the ST's keyboard connector. We've only got 4 here. There's no LED reset light, obviously. Our USB cable will go in here. Power will come from the ST. We've got our 3 menu buttons. Need to make sure those buttons actually do make contact, but it should boot up without that. So there we go. I think the only thing to try now is, well, I might just put 5 volts across it to make sure that everything still works without shorting before we attach to the ST. But then I think it's into the machine. Let me give you some news from this channel's sponsor, PCBWay. A year ago, PCBWay moved into a new factory, and now they've had time to get their feet under the table, they're able to offer some substantial price reductions. There's up to 20% off 4 and 6 layer boards, bulk order prices are down, and 5x5mm track width and 1/4mm minimum hole size designs will also see huge discounts. The event started on the 5th of August 2022, and you need do nothing special to obtain it. Why not log in now and see if your design, manufactured to PCBWay's normal quality specs, is much cheaper than you thought all of a sudden. And if you're there, maybe take a look at their CNC machining, sheet metal fabrication, 3D printing and injection moulding services whilst you're at it. See the links at the bottom of this video for more information. Right, so we've got the positive and negative hooked up to a 5 volt supply here. Haven't plugged anything in yet. Flick the switch. We're drawing 21 milliamps and we've got our menu up here. And if we plug in our USB keyboard, doink, perfect. It's popped up as having been recognised. USB keyboard 1. Now, what I've discovered is that this button works. You see the mouse speed moved up 1, but the middle button and the left button don't do anything. Now I've had a I've had a quick look, and I think what I've done is I've got the pin out of these wrong. So I think because this one here, the one that works, I've got the jumper cable going into here, jumper wire going into this side, and power's coming in this side. Whereas these two, I've got them on this side, as in to the left of the picture, and the power is coming in also on the left. I think what's happened is that actually these switches connect left to right rather than top to bottom. So I think that's just directly connected, and that's just directly connected, and that's therefore the only one switching. So I think the trick would be for me to just change the side that I'm feeding in ground to. This is the simplest way to do it. So now I'll be bridging ground from that side to there and through there, that side to there. Is that one correct? No, I think I've got the wrong one. There we go. So let's try that. So left, there we go. Now we can see it move on the screen. And middle, joystick 0 is USB, joystick 1 is USB, ST keyboard. And those are the options, and I can toggle between a D sub, which is not connected, and USB. There we go, and ST keyboard. Can't do anything there. Let's try pressing F1. Oh, there we go. Aha, that's listing out commands. So there we go. That's interesting. Space 39, B9, 39, B9. Up and down, up and down. Hold down Shift. Or press Shift. 2A, AA, 2A, AA. There we go. So that's telling us what the scan codes are that it's sending. So that's quite cool. So good. Well, I think it's time to hook it up to the ST now and see how she goes. Right, so here we are with the STFM motherboard hooked up, got the power in, got the monitor connection in, We've got a floppy drive, although probably won't be doing anything with that. And I've just got the original keyboard in here. This is obviously my STE keyboard. So because I don't have an original keyboard, that's the point. So let's just, and I've just got the standard CPU in with no accessories. So let's just flip the switch and make sure that she actually turns on. So power's going on there. I can see a green light on the keyboard, and there we go. We're booting up into emutos as we'd expect. So that's working nicely. So we'll turn that off now, and let's introduce our Raspberry Pi Pico. Right, so here we go on the breadboard. Where shall I position this? Let's just see if we can get it to sit over here for now, so it's in shot. Right, now the pin out of the keyboard connector here. Basically, pin 1 is ground, pin 2 is not connected. Pin 3, I think, is the ID activity light, so we won't be using that. Pin 4 is VCC. Okay, so those are our starting points. So this, let's do ground first. So this one is ground, and pin 1 is ground. There we go. Ooh, let's connect ground somewhere more close. Ground can go in there. Okay, do the same with VCC. VCC can go in there. So VCC, I said, was pin 4. 2 is missing. 2, 3, pin 4. There we go. So if we were to throw the switch now, that should power it up. Obviously, there's no communication. So just get those out of the way. Let's give that a quick go. Okay, power's on, and you can hear in the background the click, 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 the high speed clicking that you get with a missing keyboard. It's because one of these is floating, one of these pins is floating. So now we can introduce that. So, right, what we have here is our transmit and receive. Let's do one at a time. So I'm going to take that one out. So we want to start with transmit, I think. So, pardon me. So transmit is from pin 6 on our Raspberry Pi Pico, which is the farthest one. So that runs from all the way over here. This wire here, the uppermost yellow wire. So that is the transmit. So that should be transmit. So let's try connecting this up to receive on the ST side, which is on that connector. That's pin 5. Okay, so that's next to. Let's move this over a bit. So that's next to our power there. So pin 5. So this should now stop. If we've got this right, it should stop that high pitch because the transmit pin. Sorry, the receive pin is now being driven. So let's try throwing the switch there. We've got power there. Don't hear that buzz, 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 buzz anymore. I'm not seeing anything on the screen, even when pressing reset. So we'll turn that off again. Now let's connect up the receive so that it can get commands back. And receive is again the next pin, so that's pin 5. I believe. So what, pin 1, 2, 3. No, it's pin 6. Sorry, 1, 2, 3, 4, 5, 6. Just check that that's correct. So yeah, we've got 1 is ground, 2 is not connected, 3 is not used, 4 is power, 5 is receive, 6 is transmit. Okay, so I believe that's correct. Let's try turning her on again. See how we go. So we've got a signal there, but we're still not getting anything on the screen. My my monitor is resolutely blank, which is not good news. So let me try hitting reset again. No. Now I wonder if that's because I don't have a keyboard in. So I'm going to try introducing my USB keyboard this time. Okay, so when I turn it on, it should get USB keyboard 1. USB keyboard 1. Still nothing on the screen. Pressing reset. No, I'm not getting any luck here. Is it a problem with my screen? Oh! My speaker's over here. And listen. Can you hear that? I'll try and get the speaker close enough. Keyboard clicks. So I think it's working, but I can't see it on the screen. What's going on? There we go. Power is on. Would you believe it? What a time for the monitor to pack up. So great. Well, listen, I heard clicks. There's keyboard click. Oh, it's triggering the. That's red. Right. So let's do a bit of hold down Alt. What's going on? Have I got a, maybe the button's stuck down. Might have to get some contact cleaner in there. There we go. We're able to move the cursor with the keyboard, just like this was a Atari keyboard. It's absolutely perfect. Right. Let's see if it works with the mouse as well. Okay, now one caveat with the with this particular setup is that it can only support a single USB hub. So that's mentioned in the setup here for the Raspberry Pi keyboard project. The idea is that you could plug a hub into here and connect to both a USB keyboard and mouse and game controller or whatever, but it can only be a single hub. Now this old Apple keyboard I have here is has a little hub in it. So I couldn't connect any extra hubs onto here, but I can obviously use this to plug in a wireless mouse dongle as well. So I'm going to put a wireless mouse into here as well. We can have a look at our OLED screen when we power it on and see whether it picks up the mouse there as well. So let's zoom in. Here we go. Power's coming on. USB keyboard 1, 2. Interesting, USB keyboard 2, not USB mouse. Take the keyboard out. Goes to 0. Let's put the mouse in by itself. No, that comes up as a keyboard again. That's intriguing. I wonder if it's a strange bit of behaviour from my mouse. Right, let's try. I've got a an old Asda wireless mouse here. Let's sorry, wired mouse here. Let's try this one instead. Nothing. It seems to be powered. Let's reset the machine, or turn the machine off rather. Perhaps the inrush current was too high. I'm powering this through two tiny little DuPont wires here, which is non-ideal, to be honest. There we go, USB mouse 1. It's entirely possible that, quite simply, it's browning out, perhaps. Right, so obviously no keyboard this time. So just for completeness, I've tried plugging in my wired Asda mouse into the Mac keyboard, and it's detected it, but again, it's not doing anything. So I said this might be an incompatibility with my mice, but it could very well be just this power that I was talking about here, that this is not delivering enough voltage, and we're getting a bit of a brownout. So what I might try and do is to put a second power line on here and see whether that helps. So rather embarrassingly, I have been thinking that this is SPI all the way through, and it's not. It's I2C, and I think I've blown this up. I don't think I've blown it up because I thought it was SPI, but it appears to have died. So I've got another one of these on order, but today, a couple of days later now, I've powered this on, plugged in the same old Apple keyboard here with just this this crappy old Asda mouse again plugged in, and look at that. The mouse is working beautifully, and I must say it really is very nice actually. It responds quite well. Could do with turning the acceleration up. I don't know if I press this button a few times. Can't feel much acceleration there, but it's not bad, you know. It's much better than this this rubbish Tom that I what's this one, a Tom 2 that I had years ago and gave up with. I actually ended up building my own ST specific version of the Smalliermouse 2 with custom firmware to suit the ST better. But this has probably made that redundant, to be honest. It's very nice. I quite like it. So I think all I'm really waiting for is for that OLED to come back, and for me to be completely content that this part of it is the actual circuit is working as expected. I still haven't been able to get a games controller to work, but that might just be because I've got bad games controllers, and I don't think I've quite got the willingness to wire up a DE9 socket so that I can plug in my proper QuickShot joystick here, because it's meant to emulate that as well, but that's a lot of pins to do on the breadboard. So I think when the OLED comes back, if I'm happy with that, I think the next stage will be to move this on to a custom PCB design. So I'll update you when that gets here, let you know if I've had any other problems in the meantime. But for now, I'm very pleased with that, and I think it'll be time for a circuit board. Thanks for watching. See you next time.